بس الايميل ما بعث لنا اياه على الاوتلوك.
وديته للجميع امبارح بالليل، ما بعرف اذا ما وصلكم يعني ممكن.
ما انتبهتش صراحه.
اوكي. هو لانه اول مره فبدنا نتاكد انه يعني كل الشباب بيقدروا يدخلوا بسهوله. اوكي.
انا شهر واحد دكتور شعبتي.
اوكي خلاص، اذا في مجال خلينا ننتقل على
ولا يهمك.
اوكي. اوكي خلينا نرجع للزوم. اوكي خلينا نبدا. We have about 13 students. طبعا في ناس they were on Microsoft Teams لانه انا وديت الايميل او عملت السكادجولينج last night، لانه الجامعه هسه في توجه انه نروح على المايكروسوفت تيم بدل زوم. طبعا بالنسبه لنا doesn't matter يعني the same thing، لانه كل اللي بنستعمله عباره عن ميتينجز يعني مش اكثر. ف بنمشي مثل ما بدهم، شو بدك اوكي. فاحنا اليوم رايحين مثل ما حكيت ويجينا ميت عن زوم، بعدين شوي راح اتاكد انه كل واحد بيقدر يدخل على مايكروسوفت تيمز، عشان ان شاء الله بدايه يوم الثلاثاء الميتنج تبعنا بدل ما تكون زوم بتكون مايكروسوفت تيمز. اوكي. last time last lecture we talked about chapter 1. طبعا بدينا نحكي عن set definitions، حكينا عن السيتس اذا متذكرين، وانواع السيتس في countable null sets and things like that. for today عملت recording ل 2 lectures، واحد اطول من الثاني شويه، فموجودات على الاي ليرنينج. ما بعرف if you had a chance to before شو مثل ما حكينا last time what I'm gonna do today انه I'm gonna share with you the notes، بس مش رايحين I'm not gonna go through the notes يعني step by step، لانه السجستشن كان انه يعني الريكوردينج موجود، فهنا اذا في واحد عنده سؤال للتوضيح يعني عشان to save time ولا لا، هيك اللي اتفقنا عليه. ف do you have any questions, general questions قبل ما to share the screens with you? اوكي طيب خليني طيب وين راحوا؟ اوكي بدي اعمل بالاول هذه. اوكي كل page 5. طبعا هاي مثل ما انتم ملاحظين هاي continuation talking about sets. اوكي فهنا يعني بالبدايه نحكي عن الجرافيكال representation which is a Venn diagram as you can see in figure 1 here. just يعني لانه هذا ما شفناه من اول. by the way يعني كل اللي حكيناه so far lectures for today and last time كله straight forward، ما بي شيء يعني خلينا نقول جديد بالنسبه لبعضكم او كلكم طبعا. اوكي فهنا بالنسبه للفين دايجرام عباره، طبعا احنا حكينا عن السامبل سبيس، حكينا شو هي السامبل سبيس. هي contains all of the possible elements or possible outcomes. وهنا في عندنا three events or three sets A, B and C and as you can see B contains an A. فبالحالة هاي graphically in figure 1 B is parts of A، فبالحالة هاي we say B is subsets of A. يعني إذا شفت شغلة graphically represented like this فورا بتعرف تقدر تكتبها بالطريقة هاي. B belongs to A. By the way بدي أسألكم شباب، لما أنا أشرح بتشوفوا الماوس تبعي بتحرك ولا ما بتشوفوه؟
دكتور واضح
واضح يعني. أوكي ممتاز. أوكي ففي حدا عنده سؤال هون؟ طبعا هنا بالاول بيج هون بنحكي عن السيت اوبريشنز، هذول مهمات شويه. فطبعا هذه اول واحده تقريبا نفس الشيء، يعني as in figure 2 ما بدها شيء. في عندنا هون 3 different sets. all we're saying انه مثلا في عندنا sets A B and C. اذا كان مثلا C a subset of B طبعا مثل ما هو شايفين هون، و B is a subset of A معناته C is a subset of A، يعني واضحه ما بدها شيء. The second one is equality. Equality ف A is equal B طبعا of all elements in A is equal to B. يعني إذا في عندنا two sets A and B they have the same elements معناته they are equal. That's all we're saying in this one. The difference here, the third operation, إنه if you want to see the difference between A and B, so we have two sets A and B. So if we say A minus B, so what do we do here? We just take the elements in A, but they're not in B. يعني هون مثلا elements 1, 2, 3 all the way to 10, and B has 7, 8 all the way to 15. هلا we want to take the elements in B and A and take them out from A. يعني خلينا نقول common elements between A and B we subtract them from A. فبالحالة هاي we end up with ايش 1 2 3 all the way to 6 لأنه 7 8 all the way to 15 موجود ب B. فهاي A minus B. هلا B minus A مختلف. هلا we take the sets that are in A and take them out from B. فبكون عندنا 11 12 لأنه 1 through 10 معناته 7 ل 10 ايش they are already in B. We take them out A and B فبصير B minus A is 11 12 13 14 15. فهذا as you can see here إنه A minus B is not equal to B minus A. So that's important. Okay. And yet if you go to page 6, the same thing, we have another example. Similar example, but this is using the rule method, if you will. So A, we have a set A and B, and we follow the same thing. Do we have any question on this one, or just should I continue? Okay. If you don't have any questions, I will just continue quickly. And I'm assuming that everybody had a chance to look at the notes, and we're just going to focus on the questions that you have. So that way we don't have spend a lot of time on the notes that you already have and the recording, مثل ما اتفقنا last time. The fourth one is union. For any two sets, A and B, the union of two sets expressed as in this equation, the union of A and B. Or sometimes we write A plus B. So basically what we do, we take the sets in A, the elements in A, we add them to the elements in B, okay? And that's basically the union, just as the name, the combination, basically. So as an example one here, we have A plus B. So we have 1, 3, 5, 7, 2, 3, 5, 9. We combine them together, and we'll end up with equation 2, as you can see here. Obviously, we have common elements between A and B, 3 and 3. There's no need to write them twice. We just write them once. As long as each element in A and B are represented in equation 3, equation 2 here, that's all we are talking about. The fifth one is the intersection. Okay, basically what we're saying, the common elements between the two sections or the two sets. That's what the intersection is all about. Okay, so as it says here, for any two sets A and B, the intersection of the two sets is expressed as in this form right here, or in this expression, the intersection of A and B. Okay, so as an example here, so we have example 2A, we have the elements red, blue, and orange. B has white and blue. So the common element between them, the intersection, they are intersect at blue. Okay. and some books they write them A times B. Okay, so that's basically what the intersection is all about. Now we go to 7. We're going to talk about mutually exclusive. Mutually exclusive or disjoint, when we have two sets, they have no common elements. They have nothing, they have totally different elements. Okay, in this case, the intersection between the two elements will be 0. There's no there's no elements, there's no similarity between the elements for A and B. That's basically what the mutually exclusive. So two sets are said to be mutually exclusive if the intersection between the two sets is equal to 0 or null set, as shown in 4 here, in equation 4. And we have an example here, obviously example 3, to clarify it. Whereas example 4, obviously these two sets are not mutually exclusive, because we have some common elements between them, or we can say that the intersection between the two section is between the two sets is not 0. Okay. Number 7, it's talking about exhaustive or collectively exhaustive. Basically, let me just read it for you. A collection of sets A, B, A1, A2, all the way to AN. So we have multiple, if we have multiple sets, okay, let's say 1 to N, and these sets are said to be exhaustive if each element in the universal set is contained in at least one of the sets in the collection, which means, so if we, let's say if we have a set of universal set 1, 2, 3, 4, all the way to 10, okay? So this is the universal set. So number 1, for example, the first element would have to be contained in at least one of those sets. It could be contained in more than one set, but at least one of them, at least one of them will contain 1. The same thing for 2, the same thing for 3, and so on and so forth. So that way, when we combine them together, okay, we'll end up with the universal set itself. So, for example, as I said, if we have 1 through 10, if we have 10 different subsets, set 1, set 2, set 3, and so on and so forth. If we combine them together, we will end up with the universal set. If we did not end up with the universal set, if one of the elements is missing of the combination, معناته these sets are not really exhaustive, sorry, or collectively exhaustive. And we have an example here, as you can see here, as example 5. S is equal integers between 0 and 10, larger than 0 and 10, 1 to 9. And we have A1, A2, and A3. So if we combine A1, A2, A3, we will end up with S, which means that A1, A2, A3 are exhaustive. And at the end of page 7, these are just expressions, or let's say equations. We can, instead of, if we have multiple sets and we want to combine them, or we take the union of that, instead, let's say if we have 10 of them, we don't have to write them this way. We just write them like this. The combination of A subscript N, where N is equal 1 to capital N, where capital N is the number of sets. The same thing, equation 6 for the intersection. Okay, page 8 is talking about yet another operation, set operation, complement. And complement, we write it set, and on the top of A, or the name of the set bar, or some books they write it A, for example, and to the power C, where C stands for complement. Okay, and both of them are okay. So if we see it this way, it's acceptable. If we see it the other way, it's acceptable as well. So as you can see here, the complement of the set A, which is written as A bar here, is the set of all elements in S that are not in B. So the complement of any set will be the universal set minus the set itself. Okay, so as shown in equation 7. Okay, so for example, if we have universal set 1 through 10, okay, and we have another set is 3 and 4. So the complement of that set, the other set, the smaller set, will be all the elements except 3 and 4. Okay. And accordingly, we can say that phi, or null set bar, or the complement of the null set, obviously it's S, because the null set has none. So it would be S minus none would be S. Also, the complement of S will be null. Okay. And also the union of A and A complement, yani the set and its complement, if you combine them together, obviously we'll end up with the universal set. It's very straightforward. And also the intersection between A and its complement would be 0. And that it would have to be, because like we said, you know, there's no common elements between A and A, the complement of A, or the complement of the other set. And the complement of a set is the set itself, as shown in 9. The complement of A, it will end up with A back again. Okay. And now here we're showing an example, very straightforward example. There's no need to go through it again. So that's for lecture number 2. Let me share with you the other lecture. Let me stop here, and I think I need to go back and see the other lecture. The other lecture is very short. Let me see. Okay, now we are on page 9. This lecture's, you know, the third lecture is just 1 page here, and we're talking about some laws here related to the unions and intersections. Okay. The first one is very straightforward, you know. So is the second one. I'm just gonna let you read them. I'm not gonna go through them one by one. But they are, you know, some of them are very obvious. Let's focus on the De Morgan's laws, okay? And I have an example on that. So all of them are, you know, straightforward, nothing to it. But De Morgan's laws here, as you can see here, we have 2 parts, A and B, okay? And as you can see here, I'm describing these laws in writing here, as it says, the complement of a union or intersection. So if you have 2 sets, A and B, the union of A and B, the complement of the union and A and B, okay, the complement of the union of A and B is equal to the intersection of the complement of A and the complement of B, okay? And similarly, the complement of the intersection of A and B is equal the union of the complement of A and the complement of B. That's basically what this laws, you know, later on as we go through the probability and we go through the variables, this may become handy. Okay, so it would be nice to understand. Of course, you know, all of them are important, but this one is we will see some applications for it. And I have an example here. This is just to prove, to show that part B is valid. So for example, if we have A and B, we have two sets, okay, and the first one, the elements for the A set is between 2 and 16. The other one is between 5 and 22, as shown here. And also we have the universal set, or the sample space, is between 2 and 24. So in equation 16, we want to see the intersection of A and B between this and this. Obviously, we all can do that. And this is going to be where C is larger than 5 and or smaller than 16 or equal to 16. So that'll be the intersection between A and B. And that's basically, we're talking about this one here. Now, if we take the complement of this one, the complement of this one will be this minus C. This, the sample universe, the sample space, the universal set, minus C, which is 16. And it's going to have two parts, okay? Because this one's the universal set, it's all the way from 2 to 24, so it has a wide range. So it's going to be C in the complement of the intersection for A and B. It's going to be between 2 and 5, and also between 16 and 24, as shown here. Now, this is really this part, the left-hand side part, okay? Now, let's see if this part is equal to this part, okay? So we take the intersection, or the complement of A is here. So the complement of A is S minus A, and it should equal to this, equation 18. And B, S minus B, should equal to this. Again, this one has two parts as well, okay? So if we combine equation 18 and 19, we will end up with D, which is equation 20 right here. Now, if we combine 20 with 12, 20 and 17, they are the same, okay? Which means that the right-hand side, the left-hand side is equal to the right-hand side, which proven the De Morgan's law, part B. We can do the same thing for part A as well. Okay, so this is an exercise where we proved this one, we verified this one, and also it's an exercise for union, and especially when we have elements like this. Okay, so if we have tabular sets where they are straightforward, 1, 2, 3, 4, something you can subtract easily. Obviously, it's a lot easier than when you have sets like this. So this one you have to be very careful, because you have something bigger, is smaller or equal. But you have to be very careful as far as the subtraction. Okay. Okay. Do we have any questions? Everything's fine. Okay. So that's all I have for today. So like I said, so far so good. Later on, we might have some examples where we have to spend more time on that. Okay. So like I said, if you don't have any questions, I want to ask everyone. I have about 19 students. I want to ask everyone to join on, try to join on MS Team quickly, and to make sure. I mean, does anybody? Do you have any problems joining with MS Teams? كان في 3 students لما بدينا 3 طلاب كانوا موجودين عن MS Teams. بعضكم حاول واحنا موجودين على الميتينج، زوم ميتينج. في حد حاول لو سمحتوا؟
كانوا على الميتينجز على الام اس بالاول دكتور، سمعتك قلت لا احنا بالزوم اليوم والثلاثاء على التيمز.
فاهم، بس انا هلا بقصد انه حاول انه يعني بدي كل واحد يعني everybody is familiar with MS Teams، ما في واحد مش familiar، كلكم تقدروا تدخلوا. ها يعني كل واحد اجى. نعم
ما في اي مشكله عادي.
لانه لاست تايم بالسمر ليش انا حولت لزوم؟ انا كنت اشتغل على ام اس تيم بالزوم. باللاست تايم في ناس كانوا يقدروا يدخلوا وناس ما يقدروش. فالجامعه الفصل هذا عممت انه لازم نستعمل ام اس تيمز. فاحنا ان شاء الله today the last time we're going to use Zoom ان شاء الله يوم الثلاثاء عمموا على الجميع انه رايحين نستعمل ام اس تيم. طبعا لما اعمل ميتنج، لما اعمل سكادجول لميتنج بتدخل على الجدول تبعك على الكالندر، فكل واحد لازم يكون عارف يعني انه اميت وقته. مثل ما حكينا وقتها الساعه بالنسبه لكم 8:30 Sunday and Tuesday. واحنا بالنسبه لنا نفس الشيء، احنا all we have to do we're going to share the documentation we have and discussion. يعني it's not going to be very complex. Okay. So ان شاء الله Tuesday بالحاله هاي رايحين ايش our meeting is going to be on MS Teams. Okay. Any questions؟ ما بعرف. ما هو اللينك هو اللينك واحد مثل ما تقول. ما بعرف انه في يعني اللينك نفسه مثل ما تقول. كيف بدي اقول لك؟ انا بجوز انه مش فاهمين. لما عملت الميتنج يعني الميتنج هي نفسها لكل مثل ما تقول يوم Sunday and Tuesday. فما بعرف شو اللينك. اذا في بشوف اذا في مجال انه ابعث لكم اياه ببعث لكم اياه. هو بده يكون لينك واحد، ما بده يكون يعني كل محاضره فيها لينك. صح ولا لا؟ اذا لقيته ببعث لكم اياه وبس. طيب كيف يعني انت ما بتقدر تدخل من؟ اشرح لي بالضبط شو المشكله. انه اها اها. طيب بدي اسالك، تستعمل التليفون ولا اللابتوب؟ لانه في بعض الزملاء حكوا لي انه في اذا الطلاب بيستعمل التليفون ممكن التليفون ما يعني ما بعرفش في مشكله. انا طبعا هاي المشكله ما بعرفها لحد الان. فحكوا انه اللابتوب بيكون افضل، فما بدريش عاد. فانا على كل حال I will find the code. اذا في كود ببعث لكم اياه. اذا ما قدرتش بعرفش يعني 100% في له كود. فبحاول اودي لكم اياه لانه بده يكون كود واحد، مش راح يعني لكل ميتنج نفس الميتنج، ما في مالتي كودز. اوكي. فان شاء الله او ممكن في طريقه ثانيه بنشوف، ممكن انه واحد من زملائك تو انفايت يو مثلا. ما بعرف اذا بصير الحكي هذا. في شباب موجودين familiar with my MS Teams مثلا to invite a student ولا كذا اذا في عنده مشكله.
دكتور تقدر تعمل انفايت
كأنه شفت فيه تقدر دكتور.
اوكي. ففي حدا مثلا بيقدر يساعد زميلكم just in case. انا ان شاء الله بشوف بلكي لقيت الكود ووديه. بس انا صراحه بدي اكون معكم انه انا لحد الان مش ان اكسبرت بالنسبه للام اس تيمز، لانه كنت استعمل زوم بعدين ام اس تيمز، يعني ما صرناش زمان. فمعلوماتي ليميتد بالنسبه للبرامج هذه. اوكي. فاذا في زميلكم، اذا الشاب اللي كان يحكي اللي بيقول عنده مشكله، اذا حدا بيعرفه انه مثل ما تقول جست ممكن يودي لك مسج او كذا وتعمل له انفايت خلال الميتنج. وانا طبعا بحاول اني اوجد الكود ونوديه للجميع. اوكي. طيب في عندكم any questions before we end the meeting for or the lecture؟ اوكي. اذا ما في اي شيء ان شاء الله بنشوفكم يوم الثلاثاء on MS Teams. والله يعطيكم الف عافيه.